Good morning, students. In lecture number 3rd, I will discuss in ninth class maths polynomial. First, I will discuss degree of the polynomial. You see very attentively here, the highest power of the variable is called the degree of the polynomial. You see very attentively, first example, 2x cube plus x plus 1. Here, variable is x, power is 3, 1, 0, because degree of constant is 0. So, highest power is 3, so degree is equal to 3. Here, highest power is 5, so degree is equal to 5. Here, the constant, this 5, you can write like this, 5 into x to the power 0, because you know very well x to the power 0 equal to 1, so degree is equal to 0. And then what is the degree of 0? This 0 you can write like this, 0x plus 0x square plus 0x cube plus 0x to the power 4 up to so on. So degree of 0 is not defined. Is very important. Finding the value of polynomial. First you see p of y equal to y square minus y plus 1. It is a polynomial. How can you find the value of this polynomial at y is equal to 0, y is equal to 1, y is equal to 2? You put in place of y here 0 first. 0 in place of y, 0 square minus 0 plus 1, it will be equal to 1. P of 1, 1 square, 1 plus 1, 1 minus 1 plus 1, 0, and 1 square, 1. P of 2, in place of y you will put 2. 2 square minus 2 plus 1, 2 square 4 minus 2, 2 plus 1, 3. And second part, p of x is equal to x square minus 9. And here if you put in place of x3, you will get 3 square minus 9, 9 minus 9 equal to 0. Here p of x is equal to x minus 5. In place of x you will put 5, 5 minus 5 equal to 0. You see, you observe these three examples and you see very attentively zeros of the polynomial. You see the value of the value of the variable x or y, of which the value of the polynomial become 0, is called the zero of the polynomial. You see in example number second and third, first, second and third. Here in example number second and third, you observe that after putting the value of x, the polynomial becomes 0 here and here. So 3 is the zeros of this polynomial and 5 is the zeros of this polynomial. If you want to find the zeros of the polynomial, you solve this like this. P of x is equal to 2x plus 5. If you want to find the zeros of 2x plus 5, you make them 2x plus 5 equal to 0 and get the value of x here. Value of x is equal to minus 5 upon 2 is the zeros of 2x plus 5. In other word, you can say that in place of x, if you put minus 5 upon 2 here, then it becomes 0. Clear? Now question exercise 2.2, question number 3. Question number 3 is verify whether x is equal to minus 1 upon root 3 and 2 upon root 3 is the zeros of this polynomial or not. Check. First, x is equal to minus 1 upon root 3 here. This p of minus 1 upon root 3 in place of x you will put minus 1 upon root 3 whole square minus 1. 3 same, minus square positive, 1 square 1, root 3 square 3, 3 cancel by 3, 1 minus 1, 0. So here p of minus 1 upon 3 equal to 0. So x is equal to minus 1 upon 3 is the zeros of p of x, because it becomes 0. And secondly, in place of x is equal to 2 upon 3, you will put here in place of x 2 upon root 3, then p of 2 upon root 3, 3 2 upon 3 whole square minus 1, this 3 same, then 2 square 4, root 3 square 3, 3 cancel by 3, 4 minus 1, 4 minus 1, 3, 4 minus 1, 3, and p of, after putting the value of x 2 upon 3, it becomes it becomes 3 and it is not equal to 0. So x is equal to 2 upon root 3 is not the zeros of this polynomial. So like this you can complete this exercise 2.2 because question number 1 and 2 I have discussed and question number 3 I had discussed here and question number 4 I had discussed here. If you want to find the zeros of cx plus d, you can put cx plus d equal to 0, cx is equal to minus d and x is equal to minus d upon c. Clear? So minus d upon c is the zeros of cx plus d. Thank you.